All right, everybody, let's talk about weighted averages. So, weighted average is basically where you're trying to find an average or a mean of numbers, but some numbers carry more significance or weight. So, if you think about your grade in this class, tests count for a bigger portion of your average than, say, homework does. So, your average for overall in this class would be a weighted average. And it can show up in lots of different areas, from science to economics to education. So we're going to do a couple of examples of weighted average problems. And the ones we're going to do focus on are focused mainly on science and in chemistry especially. So I've got a problem here. It says, how much of a 70% acid solution should Mia add to 15 milliliters of a 13% acid solution to make it a solution that is 60% acid? So what we've got here are three different things. We've got a 70% acid, we've got a 13% acid, and we've got a 60% acid. So those are three different types of acids. And then we've got three different things for each of the actual amounts of acid, each of the different types of acid. So the percentage, which we just talked about, the actual amount, which we know like the 15 milliliters of the 13%, and the amount of solute in there, which is actually what makes the percentage. So we're going to do these problems basically by setting up a chart. So we're starting off with a 13% acid. So here, to the left of my first column, I'm going to write 13% acid. And then to the left of my, sorry, that was to the left of my first row. To the left of my second row, I'm going to write 70% because that's what we're trying to add to the solution to make a 60% acid. Now, the three things that are listed here are basically going to be the amount of solution, which is the amount of liquid overall, the percentage as a decimal, and the amount of solute, which is the stuff that's actually dissolved into the solution. So the decimals we can do really easily. So 0.13 and 0.7 and 0.6. Now keep in mind, when we have an amount of solution, to get the amount of solute, we would multiply the amount of solution by the percentage as a decimal. So we know we've got 15 milliliters of 13% acid. So the amount of solution we have is 15 milliliters. So if I wanted to get the amount of solute, I would multiply 0.13, which is the percentage, times the 15 milliliters, which is the amount of solution, and I believe that would get just 1.95. So there's 1.9 milliliters of solute in the 15 milliliters of 13% solution. So when I look at the amount of solution that I'm adding, which is the 70% acid, I don't know how much I'm adding of that. So I'm going to call that a variable x. And I would calculate the amount of solute in the same way. I multiply the concentration, the percentage, which is 0.7, times the amount of solution, almost said solute, solution, and that would give me 0.7x. Now, the third row is a little bit different because the third row was formed by taking the first row and adding the second row stuff. So when I started the amount of solution, I started with 15 milliliters of stuff, and I added x milliliters of stuff. So that means I have 15 plus x milliliters of stuff. Now, this third space down here, I'm going to go ahead and calculate the concentration, the amount of solute, exactly the way I did for the first two things. So I've got 0.6 times 15 plus x, and I believe that comes out as 9 plus 6/10 x. Now, that is true. That is one way of writing how much solute we have. But just like the first column where you could add the first two rows and get a total amount of solution, you can do the same thing here. You can add the first two rows of the amount of solute, and that would give you the total amount of solute. So that means basically that 1.95 plus 0.7x is going to equal 9 plus 6/10 of x. So there's an equation that we can solve. We're going to get all the x's on the same side by subtracting 0.6x. We're going to get all the numbers on the same side by subtracting 1.95. And then we're going to divide both sides by 0.1. So that tells me that I would need to add 70.5 milliliters of the 70% solution in order to bring the acidity level up to 60% of the final solution. So there is that first problem. Now, pause the video and start working on the second problem, and I'll work it in rapid succession. All right, first I will draw my chart. Notice I've labeled my columns to match my problem, so it's drink and juice instead of solution and solute. But I'm going to change my decimals to a percentage. Sorry, my percentages to decimal. I'm going to add in my amounts of drink that I know and don't know. And I'm going to use those with percentages to calculate the amount of juice. And I had to extend my box there a little bit. And now I'm going to add the amounts of juice in the first two rows and set it equal to the third row. Get all the x stuff together, and then solve for x. And that should be your answer.